Hi, Les Druven with part 6 of completing the residential heat loss and heat gain worksheet. We're going to look at the first floor rooms in this video. We're going to start in the kitchen. So the first thing that you need to do is determine the total distance of exposed wall. So you're going to measure this complete distance here all the way around, and this being our in-class example model 1966, we measured this total distance to be 37.75 feet, and so we record that distance in the PE box, perimeter exposed, for the kitchen. Next, you indicate the wall height, and the average wall height for your production house is 8 feet high. The next thing that we did was we found the area of the kitchen, and so despite the kitchen being an odd shape, we found the area and determined that area to be 188 square feet. And you put that in the area box. The next thing you have to determine is what are the wall types for this room and what is the gross wall area. When you look at the drawing, you'll notice that there is a note for number 3 here and here, and if you recall, number 3 indicated that the walls were frame plus brick. So the in total exposed perimeter for the kitchen is frame plus brick. So on your worksheet we have a frame plus brick row. In order to find the gross wall area, you take your exposed perimeter, 37.75, times the height of the wall, 8 feet. That will give you 302 square feet, and that will be rounded. Now that you've found your gross wall area, you need to determine the area of any windows and or doors. In the case of the kitchen, we actually have several windows. We have a window here over the sink, and we've got a large window facing towards the back. The front of our house is west, and so the back of the house is east. Therefore, the right side of the house would be south, and the left side of the house would be north. So we determined the area of each of these windows, and because they're both facing east, you can add the areas together, and so we had a total area facing east-west of 33 square feet. Next, we had a look at these two smaller windows. Note that the smaller windows are on angled walls. So this window would be facing northeast, and this window is facing southeast. And we determined that each window was 10 square feet, and so we put 10 square feet facing northeast, northwest, and 10 square feet facing southeast, southwest. Finally, in the kitchen, we have the sliding glass door. The sliding glass door is facing south, and we determined that that door was 35 square feet, and so we've got 35 square feet facing south. Next, you determine if there are any doors. Now, these are doors that would be something like your front door or a door leading into the garage. The kitchen does not have any doors. It has a sliding glass door, but remember, a sliding glass door or a patio door is considered glass, not a door. So the kitchen does not have any doors. Therefore, you can leave the door boxes blank. Now you need to determine the net wall area. So you have a gross wall area of 302 minus 35 minus 33 minus 10 minus 10. That gives us 214 square feet of net wall area. Then we assess the first floor header, and recall from our working class that the first floor header was assessed at 0.75 feet high, and so therefore you would take 37.75 feet, which is the total exposed perimeter, times the height of the header, which is 0.75, and that comes out to 29 square feet. In order to determine the heat loss for these different values, take the area. In this case, our south-facing window of 35 square feet times 26.89 gives us a heat loss of 942 BTUs. The heat gain would be 35 square feet times the heat gain multiplier 14.34 to give us 502 BTUs of heat gain. Continue this process, so 33 square feet times 26.89 is 888. 10 square feet times 26.89 is, of course, 269. So both of those would be 269. The heat gain for our east-west window would be 33 times 20.32 to give us 671 square feet. And then you've got the northeast-northwest window, 10 times 15.39 to give us 154. And finally, 10 times 20.15 to give us 202 square feet of heat gain for the southeast-southwest window. Then we find the heat loss and the heat gain for our net wall. So you take 214 square feet times the multiplier for frame plus brick, which is 4.39, and you'll get 940 BTUs. The heat gain will be 214 square feet times the heat gain multiplier of 0.73. That gives you a heat loss of 157 BTUs. Sorry, a heat gain of 157 BTUs. Finally, we assess the heat loss and gain from the header. So 29 square feet times 3.21 to give us 94 BTUs of heat loss. And again, 29 square feet times 0.54 BTUs to give us 16 BTUs of heat gain. Once you have completed these heat loss and heat gain calculations, you can add them up and you place the totals in the box for row 10. This is your conductive heat loss box in row 10. This is your conductive heat gain box in row 10. That's the kitchen. If we move on to the family room, we can see that the family room has an exposed wall from this point around to this point. When we measured this total distance, we found that we had a total distance of 24 linear feet. So we put the 24 in our exposed perimeter box. Once again, the height is 8 feet. We calculated the area to be 165 square feet. In order to find the gross wall area, we took the total exposed perimeter, which is 24 feet, times the height of the wall, which is 8 feet, to give us 192 square feet of gross exposed wall. Then we looked at the windows, and in the living room we found we've got one window back here. That window is facing east. So when we measured that window, we found it to be 25 square feet facing in an east direction. The family room does not have any doors leading to the outside, so once again the doors would remain blank. So that now you need to find your net wall area. So you take your gross wall area, 192, subtract the glass, which is 25. That leaves us with 167 square feet of net frame plus brick. Then we need to determine our header area. Again, the header is 0.75 feet high. So the length of the header is equal to the exposed perimeter, 24 feet. And so the area of the header would be 24 feet times 0.75 to give us 18 square feet of header. Once again, to determine the heat loss, you take the area of the glass, times the heat loss multiplier, 26.89, gives us a heat loss of 673 BTUs. The heat gain through that window is 25 square feet times 20.32 to give us 509 BTUs heat gain. The heat loss through the wall would be 167 square feet times the heat loss multiplier of 4.39 to give us 733 BTUs. And the heat gain would be 167 square feet times the heat gain multiplier of 0.73 to give us 123 BTUs of heat gain. The heat loss through the header would be 18 square feet times the multiplier for the first floor, which is 3.21, giving us a heat loss of 58 BTUs. And the heat gain is 18 square feet times the multiplier of 0.54 to give us 10 BTUs of heat gain. Once you have completed your heat loss and your heat gain, you can tally them up and put them in the heat loss box for row 10 and in the heat gain box for row 10. Moving on to the laundry, we see that the laundry has two different wall types. It's got frame plus brick, and it has frame plus block. So in this scenario, you need to determine the length of frame plus brick, and on a scrap piece of paper you would write down that distance. As well, you would measure the distance of frame plus block, and again on that same scrap piece of paper you would write down the distance of frame plus block. Now also note that the sunken laundry is down one riser, one step. And a step is generally between 7 and 8 inches, so we round that to 0.75 feet. So therefore, because the floor of the laundry is down 0.75 feet. It makes the wall of the laundry actually 8.75 feet. So on your heat loss worksheet, you're going to have frame plus brick, and you're going to have frame plus block. And so for the laundry, we found the distance of the frame plus brick multiplied by 8.75 to give us 75 square feet. And we found the distance of frame plus block times 8.75 to give us a gross wall area of 55 square feet. Now we looked for windows and or doors, and we see that we've got a door leading from the laundry to the outside, and we also have an optional door. Whenever you've got an optional door, you must include it in your calculation. The outside door we determined had a 6 square foot window in the door, and so we have 6 square feet facing in a south direction. Since the door is a standard 7 feet high by 3 feet wide, the total door area equals 21 square feet. But since we've got a 6 square foot window, you would subtract the glass from the total door area to get a net door area of 15 square feet. The door area for the optional door would be 21 square feet. Please note that a door that separates a house from a garage cannot have a window in it, and therefore it would just be a solid metal door of 21 square feet. And that's why we've got 21 square feet in the optional door row. Now we want to find our net frame plus brick. In our frame plus brick, we have this door, and so we would subtract the 6 and the 15 from 75, and that leaves us with 54 square feet of frame plus brick. For the frame plus block, we have this door, so you have to subtract 21 square feet from 55, and that leaves us with 34 square feet of frame plus block. For the header, despite being two different wall assemblies, you can add these two distances together, and we found that we had a total distance of 14.75 feet. Once again, 14.75 is the total exposed perimeter. The height of the header is 0.75 feet. So 14.75 times 0.75 gives us 11 square feet of header. Again, doing all our multiplication, we ended up with a total conductive heat loss of 1,029 BTUs and a total conductive heat gain of 202 BTUs. And again, they were filled out in the heat loss box from row 10 and the heat gain box of row 10. Finally, looking at the foyer, we can see that the foyer has these exposed walls. This is the powder room. The powder room has this distance of exposed wall, but we are looking at the foyer. So note that the foyer has wall number 19, and number 19 indicates that this is a frame wall with drywall on both sides. Also note we have a front door, and this is a frame plus brick door. So the foyer will have two different wall assemblies. From your worksheet, you should see that you've got your frame plus brick and you've got a frame plus drywall. When we assessed the foyer, we found a total exposed perimeter of 9.75 feet. However, you do need to measure the distance of frame plus drywall, and you would mark that down on a scrap piece of paper. And as well, you would measure the distance of frame plus block, and you would also write that down on a scrap piece of paper. In order to determine the gross wall area, note that the foyer is back to the normal wall height, so it's just 8 feet. And so we took the distance of frame plus brick times 8 and found 42 square feet. And we took the distance of frame plus drywall times 8 and found we had 36 square feet. Now we know that we've got a door. However, when you look at the different elevations, you can't actually see what the front door looks like. So in that scenario, we assume that there is a 6 square foot window in the door. And so we've got the 6 square feet. And note that the door is actually on an angle and that the door is facing northwest. So that's why we've got 6 square feet in the northwest row. Of course, that leaves us with 15 square feet of net door. So now the door being in the frame plus brick, we need to find the net wall area frame plus brick. So 42 minus the window minus the net door leaves us 21 square feet of frame plus brick. And we have no doors or windows in the frame plus drywall, so there is nothing to subtract. So our gross wall area of 36 minus 0 windows and doors would remain at 36. Then to establish our first floor header, we take the total distance, 9.75 feet, times the height of the header, which is 0.75, and that gives us 8 square feet of header. Note that in the foyer, the second floor actually cuts across the foyer at this point, which means that this area of the foyer is actually exposed ceiling. So you need to determine the area of that exposed ceiling. So in our example, we found that we had 11 square feet of exposed ceiling. Once again, you would simply do your multiplying, and once you've got all the losses and gains, tally them up and put them in the appropriate boxes in row 10.